At present, with the large-scale development of renewable energy, the integration of distributed generation, and the rapid development of the power market in China, the fast response of the pump storage plants, such as primary and secondary frequency control, spinning reserve, etc., is more and more important in power systems. Strengthening the construction and operation management of pump storage plants has become a key strategy of China's electric power development. However, problems and accidents of safe and stable operation of pump storage units occur frequently. A key reason is the defects of theories about complete characteristics of pump turbine and the matching mechanism for characteristics of water system and pump storage units. While physical model experiment is an important research method to study these problems. The research team of safe operation of hydropower plants belongs to the State Key Laboratory of Water Resources and Hydropower Engineering Science in Wuhan University. Established the experiment hall of pump storage plants, and developed the world's first integral experiment platform of transient processes of pump storage plants. The research team was set up in the 1950s and has been committed to the research of transient processes and control of hydropower plants for a long time, and it built the ministerial-level key laboratory of transient processes and control of hydropower plants inside the campus of Wuhan University. The research team, with Professor Yang Zhendong as the academic leader, carried out a series of model experiments for the large number of major hydropower projects, such as the Right Bank Underground Power Plant of the Three Gorges Project, the Shangjiaba Underground Hydropower Plant, and the Pengshui Hydropower Plant, etc. The research results applied into the design and operation of more than 30 large hydropower plants and more than 20 pump storage plants in China. In 2008, the research team won the second-class prizes of the State Scientific and Technological Progress Award. In December 2008, the construction of experimental hall of pump storage plants in Wuhan University started, and it was basically completed in December 2012. The length, width, and height of the experiment hall is 120 meters, 30 meters, and 18 meters respectively. The integral experiment platform of transient processes of pump storage plants is composed of the following 9 subsystems. First, the subsystem of model units includes 2 sets of reversible pump turbines and generator motors that have the same rotational speed but obviously different S-shaped characteristics, and this system is crucial for the model experiments. Second, the subsystem of waterway is the key to study the hydraulic characteristics of the system. It is composed of upper and lower reservoirs, pipelines, branch pipes, tail-raised surge tank, etc. And the 2 units share the common pipeline. Third, the subsystem of circulating water provides circulating water for the model experiments. Fourth, the subsystem of electrical control is for the excitation control, synchronization, and protection of the generator motors. Fifth, the subsystem of speed governor enables various operation and control modes for the model pump storage units. Sixth, the subsystem of converter and commutation mainly provides the functions of variable frequency startup and switch between pumping and generation of pump turbines. Seventh, the subsystem of electrical load provides RLC load for the model experiments under isolated operating condition. In addition, the model units can also operate under the grid-connected condition. Eighth, the monitoring subsystem provides the function of operation instruction, data acquisition and processing, safety monitoring for the model experiments. Ninth, the measurement subsystem provides the functions of fast acquisition, processing and analysis of various physical quantities for the model experiments. Compared with the similar studies worldwide, based on the experiment platform, the opposite results of divergence and convergence caused by different S-shaped characteristics of pump turbines and new physical phenomena such as dynamic loops of characteristics of pump turbines are observed. The results of theoretical deduction and numerical simulation is verified for studies on optimization of Guy-Van closure law, the runaway stability criterion, steady and transient performance of a pump turbine in pump mode, and stability of hydropower generation system, etc. The research team wrote the book Transient Processes of Pump Storage Units in Chinese in 2017 and published over 30 international journal papers and actively attend international conferences in the recent 3 years. The research team members actively set up international cooperation with Uppsala University in Sweden, Adelaide University in Australia, and Kathmandu University in Nepal. The team members are also invited to compile the International Electro-Technical Commission Guide for Transients of Hydraulic Machineries and are responsible for drafting the section regarding the scaled physical model experiment of hydropower plants. Currently, based on the research on prospective technology of seawater pump storage plants in the National Key Research and Development Program of China, a new experiment platform of seawater pump storage plants is in development in the experimental hall, and it is characterized by the key equipment such as the variable speed reversible pump storage units and its control system, the downstream water tank that can simulate the wave fluctuation, the upstream closed pressure tank with adjustable pressure and discharge, etc. This platform aims for laying a theoretical foundation for the follow-up construction and operation of real seawater pump storage plants in China. For the future works, it is planned to install suitable wind and solar power equipment in the experimental hall to develop an intelligent microgrid system with variable speed pump storage, wind-solar hybrid operation, and to conduct systematic research on the dynamic characteristics of microgrids with 100% renewable energy generation. The research team of the State Key Laboratory of Water Resources and Hydropower Engineering Science in Wuhan University will strive to provide solid theoretical support for innovation and upgrading of China's pump storage technology.